So standard installation of these legs would involve just putting in some screws into your work surface and then using a stretcher in between the two legs to give it a little bit of lateral stiffness. But the stretcher, in my use, would be inappropriate because I want it as a desk and a stretcher would get in the way of my legs. So I'm going to have to do something a little bit different. This mounting surface is about 4 inches wide, so I figure I can get away without using a stretcher. I think it'll provide enough lateral stability. The problem I see is that using lag screws into only 1.5 inch thick wood, that's going to be a weak point, and if I'm doing anything rough on this table, I might loosen it up or worse. So the simple answer to this is just to use bolts instead of lag screws. Just use through bolts, and that'll get a lot stronger clamping forces. The only problem that I can see is that for some unfathomable reason, this casting, you notice that it's narrower here and wider there. It's at about a 5-degree angle. This surface is reasonably straight, but this one's at a 5-degree angle, and that's going to make tightening bolts kind of difficult. I could just go to McMaster Carr's website and buy some leveling washers here, but they're rather expensive in stainless steel. I want stainless steel because I do believe that this bench, or at least the legs and the hardware, it could potentially last for hundreds of years even. So I really do want something that I can be proud of. Additionally, the leveling washers, they would work fine on this surface because this is flat, but they might not seat very well on this surface, which has a bit of a curve in it. So job number 1 is I'd like to fabricate some custom washers that have a 5-degree slope so that I can mount the bolts perpendicular and get them to properly seat. Relatively easy for this one, a little bit more challenging for this hole because you might notice that it goes from a 5-degree angle to being parallel here, so that's going to be a little bit different. So my plan is to fabricable some washers out of this 2 by 1/4 inch 3/16 stainless steel. So to do this, I'm going to use my Proxxon FF230 microscopic mill to machine stainless steel. Now, if you pay any attention to the web fora, like I do, you'll find out that the experts say that this machine just can't handle stainless steel. It's just too wimpy, it's too unstable, something like that. Well, I'm a noob, so I am going to find out in my own manner. So rewind about 20 days. I did the machining first, and then I decided to make a YouTube channel. And this is not even the start. I had already cut the pieces, squared them up, and milled one side flat. Now I'm milling the obverse. On the other side, I tried shallower passes and bigger bites, but in the end, I wasn't certain it was actually any faster than doing it this way. Doing it in a single pass with a depth of about 0.6 millimeters and a bite of about 0.5 millimeter allowed me to have a single setup to mill all 8 squares to the same thickness. The end mill's a cheap eBay special. 12mm, 2 carbide inserts. Won't be a biggie if I toast them. Working kind of weird. Notice it's clearing the workpiece here and rubbing near the edge. Wonder what that is. Let me know if you have any ideas. Nearly finished this square. Very slow going, and I got 7 more to do. Housekeeping. Gotta keep all them chips at bay. And clean up the edges. Grunt work. This is a metric test indicator, and my square is very nice and flat in one axis. But the other axis is a bit off. Let me know in the comments what sort of precision I can realistically expect. Behold, 12 stainless steel squares. Here's an edge finder. Notice how the tip isn't perfectly concentric with the spindle? Now watch it spin. Now it touches the work surface. In this case, actually, it's the parallel it's touching, not the work surface. Now it clicked out. As soon as it clicked out, that means that it's perfectly found the edge of the workpiece. Now, it's a very, very tedious job to turn hand wheel revolutions, counting them as you go. And if you can keep your mental arithmometer working, you can make it go perfectly to the center, or wherever you want at the workpiece. Here I'm putting it in the center. It's very tedious counting hand wheel revolutions. Wow. And here we go again. This is really tedious. I really would like to set up what's called a DRO, a digital readout. It'd be rather challenging to do it on this machine because this machine is really quite small. Though I imagine some cheap digital caliper I might be able to jury rig Fabricable to work with this machine. That'll be a future project. Stay tuned. Hopefully I'll get around to it. I really need to get around to it. Despite this extreme care and patience that I'm demonstrating here, I somehow managed to be off almost a whole friggin' millimeter. Now after it's nice and centered, I gotta lock down the axes and get ready to do a whole lot of repetitive drilling. Here I just put a little pip on the square to double check for centerness. Just gonna cross a ruler over it, and it seemed good, but my laser eyeball just wasn't quite up to this task. I don't know. I gotta work on my precision. I know. Gotta lube it up. If you have any teenagers in your house, about now is around the time that they start shrieking at you. Mine did. Ah, what's that awful sound? Make it go away! Make it stop! What are you doing? Ay, 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 ay. What a mess. Look at that chip. Stainless steel is gummy. Well, spring. Clean it up, clean it up. And, well, not always. Oh, there we go. Pop it in position. Lock her down. Lube her up. And rock and roll. Onwards and downwards, 2 millimeters in diameter more each time. And away we go. Millimeters is the biggest drill bit that this machine will handle, at least for the shaft size. So, last drill. To bring the hole to 12 millimeters, I'm going to use this end mill again. What's going to happen is these two flutes, they're going to like interfere with each other on each side of the hole, and the noise that they generate is just something to behold. Normally I play everything at full volume, but here I'm going to reduce the volume at least half to save your ears, and you will thank me. Clean it up, clean it up, clean it up, up, clean it up, clean it up, clean it up, up. Ah, sparkly. And dangerous. Look at that burr. Wee, wee, wee. Look at all those chips. Up and into the garbage. I did eventually go back into the garbage and I pulled them all out though, so I can make my introduction sequence. Behold, 8 squares with holes. Yep, this is sound clamping. And I use a roughing end mill here because roughing end mills, they do put a little bit lower force on your parts that you're machining. So hopefully things will work out. Let's see. More tedium. Gotta put her in position. Flip her on. 0 to Z. Very slow. There we go. It's done. Now let's move her over. And I'm going to take about 5 millimeters off the corners of all of these squares at one time. That'll be straightforward, won't it? Let's see. I'm taking really shallow bites. I'm not really certain that this clamping arrangement is going to work. But we'll see. So far it's looking okay. Try one more pass. And it's good. Woohoo. I stopped filming. I was confident. Oh my god. I really should have known that that wouldn't work. I should have not been milling in the y-axis. I should have milled in the x-axis instead. I did find a pretty interesting video on the Dudley Toolwright channel. I'll put a link to it in my description below the video. Pretty good video that he did on how to get proper clamping and machining, to consider all the possible axes in which your part might shift or move or catastrophically fail, like I did. But no big loss. I'm just going to do it now this way, and yeah, nobody will be worse for wear. And so it turned out that this clamping arrangement did work. I did gradually start taking bigger and bigger bites and taking milling passes on the climb and conventionally, and I got through it. A little bit further. And now about halfway. And mostly done. And it's nice. Really didn't need to remove these corners. I'm really only doing it for show, just to make them look pretty. Which is kind of funny, because if you think about it, they're going to be under the table where nobody sees them. But I'm going to know that they're there. Second corner. Tiny little bites. Third corner. Deep bites, almost 5 millimeters. Fourth corner. Amazingly, it held. Notice that one of those parallels got shifted. It must have crashed into the machine column. Ugh. But it held. Time to release the parts. Ooh, octagonal. And 8 of them. Wow. Scrap aluminum. Cut it. Clamped at a 5-degree angle. Fantastic. And compared to stainless steel, this aluminum cuts like butter. Cuts really easy. This part here took me only like 15 minutes to machine it. Squared it up, I did that off the camera. Sorry about that, it was pretty boring. Here's just cutting at a 5-degree angle. Enjoy. Or fast forward. The mill was growling there, but it cut pretty well. That's pretty easy. Lots and lots of little aluminum tiny bits, though. Clean them up. Sweep, sweep, sweep. Now this piece is just to hold my octagonals, so I can now mill them at a 5-degree angle. Now here we got the edge clamps, and we're locking it down. Clamps are really nice because they pull the part down as well as clamping it very nice and tightly. I used parallels to get the parts, the octagonals, in a nice, more or less true location. I used one parallel also underneath the block to get it up to the right height. Just a little bit proud of those clamps. Now, I found taping up those holes saved a lot of headache later on. Otherwise, all the little tiny chips would fill up the socket cap heads, and that was kind of annoying. Tape to the rescue. So after this is set up, all that I need to do is to mill off the surface of the octagonals. Now this is going to be interesting because the depth of cut is going to change from one end to the other end. At the shallow end, the depth of cut is going to be, well, you'll see right here, just like maybe 1/10 of a millimeter. But around the other end, the depth of cut's going to be closer to 3 millimeters. That's going to be a lot more challenging of a cut, so might as well start with the difficult first. I'm going to whip around here and do this side. Getting into position. Going to touch it off. Find my 0 for my y-axis. There we go. Now I'm going to advance a very small amount, 1/20th of a millimeter, because this is a pretty deep bite. And I know that this is going to create quite the racket. It's still not really fully biting into the material, so it's not very noisy yet. It will be. Yeah, that's more like it. Loud. Shaking the entire table. Halfway, and a little bit less vibration, a little bit less noise. It's Still a lot of vibration. Almost done and a lot easier milling now. Jeebus, that vibration was so strong that at one point a set screw in the mill loosened up completely and fell out and dropped on my desk. That was a bit of a surprise. I had to keep screwing it back in. Fortunately, that screw wasn't essential for anything, but you're going to have to Loctite it back in at some point in the future. Have to remember that one. Okay, let's release the part. Unscrew, and there we go. Ooh. Look at that angle. Beautiful. Now, 4 octagonals were to be milled a little bit differently. Part of the washer was to be parallel rather than at a 5-degree angle. Yikes! The manufacturer does recommend using only a 10-minute duty cycle. I guess this'll happen. Some nice chips. Looks good, I think. Let me know if you think otherwise, but seems about right. And one final operation to mill the parallel part of this washer. So a little bit of a different setup, not using that block anymore. Oh, touch off. And this time I'm just going to mill the entire surface, about 10 millimeters wide at a time. Depth of each pass is about 1/10 of a millimeter. That seems about right. Squealing like a pig. In climb milling it sounds a little bit better though. Conventional milling leaves a lot of these little hang-ons behind, and see, they don't brush off. Climb milling the surface. That leaves a reasonable finish. Moment of truth time. I absolutely abused this cheap Chinese end mill. Let's take a close look at it. Look at those cutting edges. I am amazed. They are not any worse for wear whatsoever. That little white thing there, that's just, I don't know, that's just a little fluff or something. That's just brushed off. This end mill didn't leave a very good surface finish. At least not on this mill, but I'm shocked. Like it worked, and it's not dead. That's good. 8 finished washers, 2 different types. Now let's hide all my mill chatter with a tumbler. Vibratory tumbler. Using the green pyramid plastic media, I found that it does leave a very nice finish on stainless steel. Kind of matte, and it doesn't cover up all the milling marks, but it does make it look a lot better, you'll see. Just wait. Six hours later, and look at them. Very nice looking indeed. I put a little center punch mark on them to identify the 2 different types of washers, the ones that are just angled and the ones that have the flat on them. Let's see how they work. One type, and the other type. Woohoo! Looks good. And straight through. Wow. That was a lot of work.